High performance Internet of Things services. Give them applause.
Thank you, Simon. With this small group, I hope anyone that have got questions or anything, just interrupt. I'm absolutely bulletproof when it comes to interruption, so don't worry about that. Anyone that with a question or anything. Can I just ask, where are people coming from here? Can someone, how many are working with Internet of Things, and how many are from Sweden? How many from Sweden here? Almost all, okay. And how many have been involved in Internet of Things and networking? Okay, nice. You're from a small company, yeah. Okay, I will give a short background first, what we're doing. I'm coming from a small networking company located in Kista. We started in 2008 and 2009, and one of the first questions we asked ourselves is that where are things happening? That was right after we have sold one of our earlier networking companies working in Metro Ethernet area, and we were sort of trying to figure out where are the next big steps or leaps going to happen in the networking industry. And our conclusion was at that point that it was Internet of Things. From 2006, 2007, 2008, there's been a large change because of new types of phones entering the market, which means that our end user, the point where the end user is actually connecting to the network is completely different than what were the original thinking. But interesting to see is that most of the technologies that were assumed to be used at that point are still to be used today. So, short thing, small company, small startup, trying to build a platform for Internet of Things that scales both in terms of performance and also as well as in the number of nodes and other things that I will talk about. We have worked for quite some time with Intel and Ericsson as our two main partners. We started delivering products actually in 2009 and have had products running at customer sites from that point. Our largest customer today is a Swedish construction company called named Kramo, and that is basically construction site management that we sell solutions for. A typical customer experience before we jump into more technology-oriented thing is that we have a customer, typically a construction site manager, and he wants to manage, he's sort of interested in something that's happening at his construction site. He picks up his phone, he clicks on an app, enters his password, or if just hit login. He goes further, pick up one of the sites that he's operating with, click on that. He gets the construction site to the right here, and he can do various operations on it and monitor and get alarms and so on. This is what we call one of possible applications on top of our platform. This is our site management app. So there's many other applications here that are possible. So this is the short story, what our customer sees. They don't really care about where things, what technology we are using. When we start saying IPv6, their eyes start wandering and they start looking out through the window. So we really don't talk about that. One of the things I want to say about this from the beginning is that we would never been able to actually acquire those customers if we had required installation to require, for example, a computer or any kind of computer knowledge. All our systems are installed by electricians without access to a computer. They basically turn on things and leave them. So any kind of scheme where you hit 3 buttons to sync and get the key, anything of that won't work. And so that was really the ease of use and the ease of installation was one of the first criteria when they were selecting a provider for this platform, for this solution. Okay, so what do we do then, aside from doing stuff like that? Yeah, we're really just a Internet of Things company that talks about how can we go from a place where we have so much different things spread out over the world that we actually want to connect and give access to the user. The part that is important is also that each of the service and each of the things that we're connecting might be very cheap, a few dollar pieces of equipment to very expensive equipment that is high performance. from the beginning, we started using video surveillance as one of the key applications for us. That means that we continuously, from cameras, record somewhere between 0.5 megabit and 5 megabit of data. This is not really traditional M2M solutions where you send 4 bytes of data every 2 hours or something like that. We talk very much about real-time performance. We talk about things like continuous video recording for multiple weeks at a time. We talk about ease of use and installation. And in all those examples, we started with a platform where we really didn't think about solving one of the problems. We tried to build what's called a horizontal solution, where you basically can stick in any kind of service on top of this and still have a single place and a single platform managing all the different devices. So from a system overview perspective, you sit on one side with a phone or an iPad or a computer. You pass through some cloud servers that everybody that sits in, where you actually have your backups, your storage. You have most of your authentication policies are implemented through the cloud servers. And then you have a bunch of stuff, and you have something. We divide the world into gateway and sensors. We call them other things when we talk to end customers, but in this group it's basically cloud servers, gateways, and sensors. And the sensors are high-performance cameras down to something as boring as a temperature sensor that sits in one place. When it comes to sensors, the most important sensor that you can have on a construction site that's always a humidity sensor. Because humidity is the #1 enemy for any kind of construction site. So we actually, for our customers, we even developed some specialized humidity sensors that were built in stainless steel that you can run over with a truck and do other things with. But in most of those sensors, like cameras, are absolutely off-the-shelf products that you can get anywhere, that you just plug in, and they're automatically configured as soon as you plug them in. Looking at some of the other ones, we monitor for equipment failure. We monitor for frost alarms, which is actually one of the large things. Some of the heating systems in the Stockholm area, when we started this about 2 years ago, is that when you heat up a construction site, to get humidity out from the construction site, you put in heaters on the different floors, usually put them in where all the stairs are. And one of the problem is that there were like 5 of them that completely froze. This is water carried energy. And 5 of them froze in the Stockholm area in one winter. And that was multi-million accidents, basically. In none of the cases, it was the provider of the heating equipment that failed. In 100% of the cases, it was actually human fault. Someone left the door open, and by the chimney effect, it actually cooled down the whole system, and the whole system froze as ice or block. So we looked at those kind of things. Motion alarms is for security, not that much of a problem. Energy monitoring, we talk very much about moist alarm and smoke alarms. So this is what the environment that we work in. Aside from working with industrial sites, we start seeing also other types of customer that we use for our application. We basically see a more traditional end user as a home, where you actually have a bunch of things connected inside of your home. We divide it into security, safety, and then you have some of the convenience factor turning things on and off, like lights and so on. In most cases, we talk about remote operation, which means that we go over internet in order to reach to the different devices. We don't really talk about home automation when you sit at home and try to control things. Much more about you are far away from something like a boat or a house or something like that, and you want to be able to monitor it remotely. Okay, so how does that, when we start moving into what kind of technology did we decide to work? Yeah, we try to understand and try to divide our customers' different needs up into pieces, and then we split down to build basically an architecture and platform around this. For end users, we only show the right side of this. We show a triangle with 3 sides. We have servers, we have sensors that sit on the other side of the internet, and then we have customers to the right, okay? We never show anything more complex than that. That doesn't really work. Behind this, we always try to divide the problem into smaller pieces. The first part that we see is that we have some, what people call apps today, which is how the end devices actually connect and gather data and show a graph or something like that. And then we have our cloud servers that are connected down to gateways. And if this connection happens to go over a public carrier network, a 2G or 3G, it's usually considered M2M. If it happens to go over fiber or something else, it's really usually not called M2M in our space. We support both things. And then we have sensor networks that can be any kind of local area network, security network, or anything else. A couple of things that we learned was when we started building this was that trying to deliver one component in this kind of banana, as some people call it, is almost impossible. And that is the natural point for small companies that you say, okay, I want to deliver this piece. And because I deliver this piece, I can sell it into the market, I can grow my company, and get something to happen. Problem is that if there is no well-defined interfaces that you talk to, how can you sell a small piece of a bigger thing when you cannot really fit it into anything? So one of the things that we did also as a choice when we back in 2008 and 2000, in order to actually see revenue and start getting into real customer problem, was to say that let's try to do an end-to-end solution, but let's not try to solve all problems in the first release of our product. Let's try to build something that goes all the way from the phone all the way out to the sensor, and let's solve it for the specific category of customer we have, and then start to kind of widen this pipe in order to provide more services and more things into the system. So a couple of things that we actually learned from that was that the first thing, trying to solve, if you only want to deliver one small piece of this, for example, if you want to deliver a sensor network and you want to deal with something like automatic provisioning, how you set up the system, how you turn it on, how you enable encryption, and you do all of the things, and you only have access to the small piece of the sensor network, it's almost impossible. It's very complex and a lot of things to do. But if you actually have access to the whole banana again, you can actually use the cloud servers to help you with authentication. So by doing the whole end-to-end thing, what we tried to do from the beginning was to actually pick the right place to implement things instead of picking the place where we sit. And by doing that, we could actually utilize the cloud servers to make the sensor network simpler, as well as we can make assumptions about the sensor network and the internet connection that could make the cloud service more efficient and also more scalable. This was one of the first part. So many challenges were actually identified when we started this. The first challenge we saw was scalability. Many locations. Locations is basically a group of sensors, but that is aggregating data up through the cloud through one gateway. One customer had said, unless you can prove that you can support 100 million locations, okay, you're not in the game. So 100 million means that you actually need to have a very scalable and sliceable and cloud service where you can basically have service anywhere in the world. The other part was that you want to be able to have many sensors on one location, and they can be of any kind of type. The amount of data that you need to aggregate, if you want to get all the data up into the cloud from video cameras, it just means that normal 3G and 2G connections won't work. So by trying to make a simple thing, everything in the cloud, pieces start falling apart because we couldn't really transfer that much data into the cloud. And also, scalability for us, we relatively fast learned that it's not just trying to build a really good, expensive. If every device costs $700, the number of devices we will sell is not high enough for us to get rich. So when we talk about scalability, we said from the beginning is that we need to be scalable in order to build big things, but we also need to be able to build cheap things. So cheap things with limited functionality and big things with a lot of functionality that is more expensive. That is for us the scalability we needed to put into a single system. Again, more things that were large variation in internet connectivity, especially when you work with wireless systems. You can have minutes of loss of network or weeks in some cases. We also saw a lot of legacy systems. Legacy systems with any kind of ugly 70s, 80s, or 90s kind of protocol, many hardware-oriented, no network thinking at all in them. They can be called things like Modbus and one-wire and CAN buses in cars and you name it. And in each of them, you ended up building device drivers on very small devices and different for every kind of bus. This didn't really scale. The last part here when it comes to connectivity was video, was that we fast realized that if you want to do video recording and you want to have continuous recording where you can roll back for multiple weeks, and you want to have an internet connectivity that actually someone wants to sell to you, you need to have local storage for video. And you need to have a method for the user to efficiently deal with this, which I will show a little bit in a while. So the ugly looking reality to us was something that were not just the world was not simple. We couldn't say that everybody is using this tool or everybody is using this. We really saw internet connectivity, cloud servers. We had some gateways that were connected into cloud that were a $2 device. We had other things that were a $1,000 device. We had someone with a gigabyte of resources. Many of our devices have 16 kilobytes of RAM. Trying to talk to saying that, okay, 16 kilobytes of RAM. For people that are that old as me, they remember that 16 kilobyte, you could actually do things in that. Today, most programmers, I think it was one of the big networking companies in Sweden that told me that if you have less than a gigabyte, what can you do? And that's really where we were coming from. But we were seeing all of these kind of different, and we saw all of these kind of layer 2 technologies we see here. And the three ones that comes to mind that seems to be part of the future is obviously Wi-Fi and Ethernet, but as well, we also see 82.15.4. And 82.15.4 gives us actually battery-operated devices today over wireless, relatively low speed. And if we want to try to tie this together and try to have a single platform and get it, really complexity is where we fail. It's like always. It's not how you can build it, it's how you need to build it. You get something like a Modbus up there where things don't even have serial numbers, and it's almost impossible to use Modbus if you don't have manual configuration. We have other things that are completely non-network thinkings, like general purpose ports that need manual configuration that an electrician will never get working, and so on and so forth. And we try to, with all this ugly looking reality, what do we need to do? So relatively fast, we ended up actually, first, the horizontal application where we can support the mix of services was really a hard requirement. None of our customers, many of our customers say that, oh, it's this thing we need. And as soon as they get that thing working, they have 3 more things they want to add to it. And those 3 more things is that it's usually security, video cameras, or something else that they want as a second thing. The first thing can be anything. It could be a humidity sensor, a motion detector, a water alarm, whatever. And then all the other things comes. And this is for every customer. One of our largest customers said initially, we are not interested in video cameras. And they say, because video that really doesn't bring that much value. Not a single site that they installed are without the video camera today, which is something that, for me, was actually news. I didn't think the world was going to do that, because everybody wants to see and have a feeling of things in their phone. So having a bunch of stuff, trying to network it together, and also have what's called a zero configuration experience was really requirement. It wasn't really, it was our customer telling us, unless you have that, we won't sell a single thing. So how did we do this? Yeah, first, all networking, all sensors are talking IP directly from the smallest sensor that we can find. That is the first part, because then we can basically build, from a Java application, we can get a socket, send UDP, typically we're using UDP or TCP, and we can actually talk to individual sensors. Second thing is that we add those protocols that needs to in order to automatically configure networking. Unless we get networking up and running without touching it, doesn't matter what we try to do otherwise. No one is going to help us. So we added all our devices, we added automatic discovery. We usually use things like UPnP and MDNS. We start using automatic provisioning. This is setup of encryption keys, all of these things, without touching the device. No buttons to push or anything like that. We had to include automatic firewall traversal. This is also where, when you come from, I got a PhD from KTH in networking, and from a theoretical perspective, you don't need to think about NAT gateways. In reality, they exist everywhere. So you need to have firewall traversal, and you also need to continuously manage all devices. This is providing a managed service to the end customer, because if he unplugs a system, he wants to know about it. He doesn't tell us when he do it. Finally, we realize also that we have multiple platforms that we want to run this on. So what we did at the end was split the problem in two pieces. We basically have almost stateless sensors, and we also have very stateful servers, where we save all the states. And all our state today is located into Java VMs. This is basically how we try to avoid building too much at a too low level, and to offload the smallest devices with all the complexity of dealing with, not basically our devices or sensors today, they provide data. They don't know how data is used afterwards. And this works very well until you start talking about something like motion detector for video cameras, because you cannot do it in the core. You need to do it out at the edge. Okay, so what did we do on top of that? We did what's called virtual device drivers. Inside the Java application, we did full device driver for things like Modbus devices, one-wire devices, and other things. This meant that we could actually implement device drivers inside of Java that talk over an IP channel to the end device, and very little state on the end device about what actually the content. The great news with this is that moving a hardware interface between an adapter to something else and to the third thing, you just plug it in and it pops up and you get all the functionality the first day. What this means is that our adapter there will not know what kind of devices we're attaching to the adapter. If we take a very specific example, if someone worked with some legacy system called one-wire, there is many different types of one-wire devices. And if we have a one-wire adapter, we convert all the one-wire traffic into IP traffic. And by doing that, if someone comes up with a new one-wire device, we don't do software upgrade of the adapter at all. We only do software upgrade inside the Java VM. Everything else is static. So what we did here was that we created a hardware abstraction layer in order to create the possibility of reusing this code much more efficiently. And those virtual device driver, they run either inside our gateway when we do it for things like video and so on, or actually all the way up in the cloud servers. So we can have a $5 device that talks directly to the cloud, and where most of the device driver work and the heavy lifting is actually in the cloud. And in some cases, this worked really easy. But if someone worked with something like a one-wire and know that temp sensors, they have hard real-time requirement. They actually do put the bus out at 5 volt, wait for 700 milliseconds, go back, do this, and so on. This is an operation that is really hard to separate over a network where you have a variation in delay that might be 30, 40 seconds. So what we actually had to do here is that what our virtual device driver layer do is building microcode that it actually sends out to the device, where basically all the path of actually non-interrupted operations are actually inside a single UDP packet. By doing this, we could separate some of these real-time requirement, the devices with real-time requirement, and the cloud completely, and actually have virtual device drivers that you simply deploy on the servers, and they're available to all devices. This is a bit of the heavy lifting of Java that we did very, very early in order to scale it to many kind of devices. So what did we end up with? First, we have lower support cost. Getting a new adapter, a new sensor is a much more straightforward. The work up front is much bigger, but afterwards, replicating this in many different sensors is relatively easy. We get higher functionality. When we add functionality to the top-level device driver, every single device in our system will automatically get access to that functionality the first day. And also, the amount of code reuse that we do is much, much higher. Our view is that anything we can code inside the Java VM, both in terms of programmer efficiency and other things, will reduce the load and increase the quality of the code significantly. So, I talked about this. This was the triangle that was easy. When we see how we partition things, basically, among the objects, we have the ugly things like zero configuration, we have a lot of networking issues, we have security, firewall, and all of those things. That's what usually is the problem in the sensor part. In the cloud part, it's much more about backups, security, client, server thingies, many APIs towards our customer clients, and so on. And also about provisioning. How do you provide and how do you separate customers in various ways, and how do you give different customers different privileges? Traditional IT system problems. At the customer, using a phone or something like that, it usually, okay, are we supporting Android or iPhone apps and all of those kind of operations? So the problems are not really overlapping that much, but they need to come together in one place, and that's what we're trying to do inside our platform then. So this is what our platform looks like right now, is that basically low cost, kind of a few kilobytes of sensor on one side, and you have a phone on the other side. And we have one gateway that might be very small or very big, depending on, and then you have actually the cloud servers. And then we have applications that goes between the cloud server. The code, the source code that we run on the cloud server, as well as the source code we run on the gateway are identical, basically. They use the same source tree. And we move dynamically functionality between the gateway and the server, depending on what kind of services we want to provide. Sensors, yeah, they are small. This is a typical small sensor that we have, cost about $1 or $2. We look into how we scale them. Sensor platform, we talk about something like a $5 device. We talk about micro gateways, something that you can find inside the car or something, maybe $15 kind of price, plus 3G modems, or 2G modems, depending on what kind of performance you want. And then we have gateways, and these are the guys that run the full Java environment. Either they are, and think about the standard off-the-shelf ARM or x86 with a gigabyte of RAM. That's basically where we run our application. And then we have the servers. And if we split this up into different pieces, we see that we sell many, many hundreds of the sensors for every large gateway we sell. And we don't sell that many cloud servers either. But this is kind of where the different parts of the architecture fit together. From a user interface, yeah, there's a lot of data to show, many things like energy, mix of cameras that we see down to the left. We see many kinds of, here we see the three things, energy, temperature, and humidity, which is frequently that you want to show. And here is a more concrete example of how we deal with video in our system. And this I want to spend just a few minutes, because this is what breaks the simple architecture. This is a construction site. What you might not see really, this is the web interface, it's not the phone interface, that looks a little bit different. But we have a window here to the right, which is actually our camera viewer, as we call it. And first on the top, we have a scroll list of images, which is snapshots taken every 10 minutes. If we look at it, we can see that the third image from the left up there is without the tractor, and then you have the machine standing there on the next picture. So in those 10 minutes, we actually saw that the machine came there, and in some way, something happened. We have a view here of the current view, which is now, when we're looking to it. And we can see the red dot below. It means that it's continuously recording this to disk. And when it's gone for a couple of weeks, it starts throwing away the oldest one. And this happened local to this construction site. When we log in through the portal, we automatically get this kind of view. But we don't upload those 250 gigabyte of video to the portal when the customer asks for it, because at the 500K uplink, it's going to take forever. So what we actually do in the tool here is that we talk directly down to our gateway and use the different scrolling mechanisms and so on, that for the user, he thinks that he has right access to the video. So when he can do here, he can pick a different time and date, and he can roll back 2 weeks, and he can start watching that video, or he can download it to his PC, or do all of these things, without actually uploading all the video over the uplink. This is how we try to save in order for a customer to be able to use a traditional 3G uplink in an efficient way. At the bottom, we can see, for example, that the yellow dots there, that is the snapshots that happens every 10 minutes. And then we see actually the recording rate that the camera do in green, which is how much bandwidth it consumes. And this can, of course, be used to see when motions happens and so on. So by picking a set of tools, how you actually can provide data to the customer so he can pick what he's interested, instead of trying to do more complex processes like compressing data, analyzing data, sending it to the portal. We basically do different views for the customer that he can pick. And even a naive user, a user with no computer experience more than using an average web browser, can actually use this to find this video, download it to his laptop, send it to the police, or do whatever he wants to do. And this without actually costing a fortune in fiber connections everywhere. Behind this, we see that we have we actually have 3 cameras here that are all operating at the same time. But this is the thing that where we actually had to move functionality between the portal and the gateway dynamically, depending on what kind of devices the customer do. We could never done this if we hadn't from the beginning actually used the same source code in both places and the same device drivers, because the device driver itself will actually move between those 2 sites. Okay, that was my, yes?
You said that most customers, many customers don't ask for video.
Initially.
What are the reasons that they come to think of when they realize that, okay, I think I want to have video? Is it mainly security reasons? Or
No.
what is it that
We,
they see in the video that they like, that they can see?
the parts that they like is that they want to have a feeling for what's happening. That means that the first camera that people put in a place is to know what cars is standing in front of the coffee house. Where is it? They pick it up and say, oh, he's there now, let's go over there and talk to him. It's relatively unspecified kind of getting closer to the system. So the first part is that in the 80s and the 90s, video surveillance systems that were like a room where you have people that didn't do anything but sit and watch monitors on the wall, okay? That is not at all what our customers do. Our customers, they look for images and video 1 minute at a time. They pick up their phone, check, okay, what's happening there, turn it off, and they use it for 1 minute, and then they go on. And they do this 5 times a day. And they don't have all have busy lives in other ways. And they want to know things specific. They want to know, is the door open? Is the machine standing there? It's kind of those abstract things in a very, very fluid environment. We cannot build a sensor that knows when this machine is standing there. It's not practical. But video cameras can sort of be generic sensors that you don't need to configure at all, and you can still get data from it efficiently. So as soon as you see that a video sensor costs a few $100s, they usually pop in a few just to start with.
So it saves a lot of driving around in the car and visiting the sites.
Yeah, and it also provides you with, never underestimate the value of showing off what you have in your pocket when it comes to those kind of things. I think I had, people think, this is an engineering crowd, basically. So, there was one electrician at Cramo. What he wanted to do was that he wanted to put all the lights on the full construction site, that he could turn it on and off in his iPhone. Because he lived like 3 blocks away, and he could turn on and off the whole construction site from home, okay. And then I started asking, okay, so what is the real business value of that? Yeah, I don't know. But the business value of doing all the work at the construction site was that they could actually reduce the energy costs during nights, okay. So the reason that the system was there was a good one, but there was a lot of fun ways they could deal with it. There is, of course, there's bad ways as well. It's that we had one guy that fell and died just in front of a camera, and then you have it recorded and everything like that. There are those kind of things as well. But we try to avoid recommending our customer to have cameras to actually use them as surveillance tool for people, because the integrity issues are usually. We try to avoid having them to use more advanced cameras like PTC cameras that is movable. The reason is that those are very good when you want to do personal surveillance on specific people. It's not really the kind of environment we want to work in. And we want to use the cameras, because cameras, as someone said, it cost me $50,000 to build sensor to know if the roof of my house is blown off. It takes me 1 second to see that my roof blown off if I look in the camera picture. So it's actually that it complements the rest of the sensors quite well. Does that answer your question?
Absolutely.
Okay. Any other questions? Okay. No other questions. I think we are done. Perfect.